Oh, hey everyone. Welcome to On the Edge. My name is David Abel, your host. This is the .next series where we actually bring together cool technologies that are going in the industry, and I kind of do a light board discussion around how you could take multiple products and all these new technologies and leverage them to get a great outcome. Let's jump right in. So as an actual understanding of what's going on today, I want to take in the old world that most large enterprises deal with. And most of this technology I'm about to talk about is really around the bigger enterprises. The what I'll call the mid-level space and the smaller customers who use IT functions. Most of them in the smaller level are going to kind of move probably to the public cloud because it removes all the complications that we're about to talk about. And the price benefit really makes sense. When you get in the mid-range, it's kind of a trade-off, and it depends on where you're at and what you're doing and how much IT is part of your business and how much is not. Like something like email. Email, it's gone. Most people decided that's in the public cloud. There's some that have, for security reasons, they haven't done it. But most people said, you know what? I'm getting out of the email business. And so that's an example of a software as a service that really has kind of taken over the industry. And in the past 10 years ago, it was unheard of to outsource your email. People were like, no way. Now it's every day. Everybody's using Office 365 or Gmail, or they moved it out someplace else. So it's a very common thing. So this technology I'm about to discuss is really about larger enterprises, the big mediums and the ones that are enterprise that are really going into the terms like cloud native. They start talking about Kubernetes, and you hear those words. You hear the word Istio and Service Mesh and OpenShift and Rancher, Diamante, Platform 9, all those different terms that as an IT operations person who's used to handling VMware, you're like, I don't need to know about that. It's not going to be anything different. But I got news for you. It's important you listen. So let's go to the anatomy and make you understand kind of where things are moving to. And I'm going to introduce some new cool vendors like Liquid who are really changing the game so you can see what people like Facebook and even Google and other people do. They don't buy traditional servers. They do things very differently. So I want to kind of walk you through why that's going to trickle down into everybody else eventually. So traditionally in an actual environment, you have all these core components, and this is a subset of those. You have big storage boxes just like EMC, NetApp, Hitachi, all the big storage. These things are loaded up with disk drives, and they just serve them out to whatever physical servers need them, whether it's a hypervisor that's a physical box that has VMware ESX on it, so it can become a machine that handles multiple VMs, or it's a big Oracle server or whatever. That's what these big storage boxes are there, and they do a great job at it. Most of those are connected via fiber channel. Some are done via iSCSI, which is network related, but in most large shops, so there's still a tremendous amount of fiber channel in there. Then we get into the network components, as you see right here. These are just representing network switches, and there's hundreds of them all over the place, but they're all over the place. And these little pink little triangles you see here look like A's in some cases. These are things that you have to maintain the software, and you constantly have to maintain those things and keep them up to date. And there's a lot of work associated with it, but let's just keep going through so you understand kind of what I'm talking about. Virtual Center, VROPS, NSX, these are all the things that work with a hypervisor that all of us know around virtualization. Almost every shop out there today is using virtualization. 10 years ago, that wasn't true. So things are changing. These are all the physical boxes. And I drew them vertical like this. Blades were a big deal. And there's still a tremendous amount of blade technology being used in the industry. But there's been a kind of a shift, kind of going back to pizza boxes, because to manage blades, there's a lot of background technology in the fact that the mid plane has to be maintained. There's software in there. There's switches in the back of the big enclosures, and you got to maintain those. There's interconnects that actually have to be maintained and all the stuff that's associated with it. So a lot of people are like, that's too many things, and it's too easy to mess up, and it causes a problem. So they're like, I don't want to do that. Then we have NSX software that's inside, not just in the control plane, but on the data plane that's here that has to be maintained. Virus software that runs within the hypervisor that is a centralized service per host that has to be maintained. vRealize Automation, which is the automation platform, whether it's VRA or it's CloudBolt or it's whatever you're using. I mean, there's a lot of software there, and it's very complex and hard to maintain, and that's being fixed because they knew that was a problem, but it's still there. VRNI doing a lot of stuff with network mapping, and you got to maintain that and pay for that. Virtual Palo Altos or virtual big IPs, with some people F5s, or virtual Avis to do load balancer work. That's all there. As you see here on this side of the coin, there's a bunch of other players I could put here that most people have, and they have to maintain. Then we have the latest in APMs, application performance monitoring. Datadog's huge, New Relic's huge, AppD's huge. It's all over the place, and they're aggregating all this data up. Then we get into physical stuff at the top side, and all of our customers in large enterprise have firewalls, load balancers, IDSs that are not virtual like down here, but they're physical, and they're because they're doing a ton of load. And then we have a bunch of systems around security and all the different key management and all that. And then a lot of companies have all this noise, all these things generating alerts. They go to technologies like Big Panda, because Big Panda takes all this noise and sends you one email and not 15,000. And ServiceNow does similar things. They have a service that does the same thing. They have a best in breed, ticketing system for doing tickets or change control and those things, building a CMDB that allows you to understand what broke. So I've just shown you the core operational components. Then there's thousands of virtual machines in here generating a bunch of noise and stuff. We got logging platforms. I mean, this is just a subset of it. But what I'm getting at is all the stuff I just described, all that complexity. And one of the reasons the industry is moving in this direction is they're moving away from this. All this. They says, you know what? Everything below, like here, I want to move to the public cloud. I want to get out of this business. I just want to care about my apps, how my apps are running. Let me just go to the public cloud. And so they go, you know what, we're out. And they just, boom, send you to the public cloud. This goes to Amazon or Google or Azure is doing really well right now with a lot of our customers. So that's where they go. But then they get out there and they find out it's not horrendously better, and it's almost in some cases more complicated because that's someone else's data center and someone else's control. And when things start actually going wrong, guess what? You can't outsource responsibility. You're always going to be responsible for the performance of your applications, no matter. You can't say, oh, it's Amazon's fault. They're not going to care. You're going to be responsible for it. So that's where they say, you know what? We need to have a better answer. I don't want to go back to that, but we need to do something different. So what's happening in our industry is people are shifting from going like full-blown here. Say, you know what? And then we go through all the differences in the models because it really changes IT operations. Because what happens is when you move to containers, all the definitions and all the stuff that was so hard to do here all almost become the application delivery team's responsibility. As an example, NSX, being able to go in here and do what's called microsegmentation. I'll go ahead and write it down. Microseg. Theoretically was a great idea, and it's something really cool to do. But once you get into the implementation of actually creating mappings of thousands of applications and who's talking to what on what port and being able to apply those rules to individual VMs to do it in a brownfield and existing environment, unbelievably complex. Unbelievably complex, and most of those projects end up not doing near what they thought they were going to do. They might do a base OS level, policy, but then after that, they're like, this is too complicated because it changes. And things get, the moving around has been solved by the way it tracks the VM, but the problem is it's the changes that happen. Every time there's a security update, every time there's a feature update, they might open up new ports. That doesn't work. It's got to go to somebody to get fixed. And they can't fix it. They don't know why, because they didn't know a port changed. It takes them a while to figure that out. Then they have to go and add the port and change the policy. Doing that across all your applications is just too much. It is literally just too much. So most of these projects fail, and you just do the basics. So make sure you can see me here. So that's what happens. But guess what? In the Kubernetes world, in something called Istio, or they have it just Service Mesh from Red Hat, what it does is when you deploy the application, you actually specify who talks to who so you can build the actual, effectively, the lane so they can communicate inside of Kubernetes. That's what NSX always wanted to do. So it kind of takes what needed to get done, gets built at the time of deploy. That's great. So the example is also, in the future, you built and paid for ESX, as an example, to run the hypervisor. Well, you can, inside of a container platform, build a container that runs an instance of KVM, and then you launch a VM on top of it. Then you can apply Istio and Service Mesh to this VM. So guess what? You just took what was so complicated and everything over here. You have the YAML and definitions that's defined by the actual application owners, and you can apply microsegmentation at the container level with this VM. So you get the value of what you wanted to do here, but it's done a completely different way, and it has to be built by the app team. So the poor IT operations person here who's like, I can't do this. My head's going to pop off. This is insane. You can come over here and do them one by one, and you can do it, and it's a natural progression. As the app is upgraded, they update the policy, and they deploy the policy when Kubernetes here says, you know what? kubectl is the actual command you run to actually instrument Kubernetes. You tell it to deploy, it pulls in the actual Istio, what's called a YAML file, and it actually comes in and deploys it across this infrastructure, which we'll get into in a second why it's so different. And guess what? All these images are loaded in the image library that kubectl pulls from. Git, or is a place where they download the stuff, but then they have a local image library for where all their images are, so they can run, let's say it's a Docker image, and then it deploys it to run wherever it needs to, whether it's a public cloud or private. Now, we see that now virtualization people now have to understand that you have basically a micro hypervisor with a VM on top of it. And this can scale out horizontally and get thousands of VMs. I'm told that's exactly how Google does it today, or maybe that's not totally true, but I know other customers that I can't say, they do this. And it works great. So they have the ability to run whatever they want. Now, the interesting thing that I want to go over with today, this is very neat, and just so you know, I put this up here, Prometheus. It kind of takes the place of VROPS. And by the way, it's free. It's open source, and a ton of people use it. Now, it doesn't take the place of a New Relic or Datadog, but basic monitoring and understanding what's going on and see how things are working, that's there. So the cost models drastically change, and there's a ton of detail in here that I'm skipping, but just so you know, there's a ton of things that you used to do here, and there's other tools that are different, but they provide the same value to you over here. So as an example, just to get into a little different story here, one of the things that all my operation teams need to know about is there's technologies that are coming from companies like Liquid. And what they're going to do is allow you to split up the compute instead of buying a rack, and it's just a set of servers that has this much RAM, this much CPUs, this many NICs, this many GPUs, this many disk drives, this kind of fiber channel card. What they're doing with composable architecture, and it's important you look at this stuff, is they can have all the hardware, all the drives in separate chassis. They can have, a math processing unit where it says offload there, completely separate. GPUs, totally separate. Fiber channel cards, network interfaces, totally separate from the actual compute. And what they do is they have a PCI bus that's connected across, effectively, you create your own backplane. And they can compose on demand the needs of the CPU. So this machine needs 3 NICs. So you go and grab these 3 NICs right here. If you want 2 of them that are redundant, you can do that, but I don't want to put that on the board. Oh, I need 2 fiber channel cards? Okay, great. I need 1 GPU. I need to have about a terabyte of disk space. Boom, 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 boom. We got this. And you say compose, you turn it on, and it's on this machine. It gets everything it needs. Oh, the next machine? Okay, we want to do that. We want to do some more. And then based on the load, you can drive it up, and you can consume this as needed. You can add disk drives as needed. You don't have to do like here in Forklift, we need an extra slot. We don't have enough slots in that machine to get the NIC in there, so we got to buy new servers. So buy a whole new server, slide it in, and take this server out. What do we do with this thing? Well, I don't know. It's older. We'll sell it off, or we'll just stick it in the corner, what usually happens. This is where the world's going. This is how the Facebooks of the world do it. This is how the Googles of the world do it. They just buy commodity servers here that have certain amount of CPU, certain amount of RAM. Everything else is just basic. Everything else is someplace else. They do that like the Open Compute Project. If you haven't seen it, look it up. Great stuff. So this is the start. I'm going to have a much deeper dive on all these different technologies, but I'm trying to make people see that this is where the world's coming. This is the next phase of IT. This is where people who are not in public cloud that have to be on-prem to get their cost model down. These are the technologies that are showing up. And this is where the companies that are a little bit more leading edge, they're already using this stuff, especially for big data, scientific, any kind of work like that. This is the most effective cost model. This takes the dollar figure from this. Let's say you went traditionally this way, it's 10 million. This way, 5 million, 4 million. So, and it's way more flexible and it's way more powerful. You get the exact same amount of capability out of 5 as you do out of 10. So it's making big inroads in the military and large scientific shops. General compute, you don't need all this fanciness. You can just use traditional servers and just do Kubernetes and still get unbelievable bang for your buck to get a platform to run as many VMs as you like with containers and get microsec technology in it that you don't have to pay a ton of money for, and it's not as complicated because other people have to do it. Everybody's involved in the solution. So I'll come up my next one and I'll talk about this slower and in more detail, but really appreciate you watching and talk to you soon. Thanks for watching. Hey everyone, I did some reviews and realized that I forgot to do some things. I want to add that back, so I'm going to use the power of Thanos to go back in time and see what I can do here. So one thing I forgot to explain, and so people understand the namespace, if you're not used to the actual Kubernetes world and how things function, but the namespace is effectively a logical barrier around your application and where all your stuff is. You can have multiple applications in a namespace, but it's just a logical way that things are grouped. I drew it up here, but I forgot to explain it. Sorry about that. The other thing that was important for me to talk about within this world that I think that I'm going to have another meeting, another session on to talk about is what I call the game changers. The game changers for the old world and virtualization was the P2V process. P2Vs made it possible for people to take old stuff, physical, and convert it into a virtual machine. And that, without this technology in the virtualization world, it wouldn't be what it is today. I had a company, that's all we did. And, we did virtualization consulting, but a lot of it was P2V work to migrate everything over to see the realization and the value to the business. What I just discovered and some things that are going on in the world that's a little bit outside of the generic Kubernetes is Google with their platform called Anthos. They have an actual V2C process, virtual to container process. Now it's only going to work for probably, I'll say 70%, somewhere like that for your things you want to convert, and primarily Linux right now, but they're working on Windows. They can convert general web apps. The stuff that's not like databases and that kind of stuff. It'll allow you to convert virtuals into containers. So this little KVM shim I talked to you about, you don't need that. It goes directly into a container to run general purpose applications. So that is where the technology is going. And one thing I didn't cover, all these little things I drew up here and all these costs and maintenance and everything else, this gets reduced massively from a cost perspective. Because these big storage devices, with this stuff, gone. Storage, gone. The big cost, not that you don't need storage, but the big cost is gone. Fiber channel switches, gone. We still need network. We got to be able to get to stuff, but all this different stuff, NSX, gone. VRNI in this respect and how it works, that cost, gone. There's other ways of doing it. The ideas around, Omni load balancers, all that, you can use those, but there's built-in load balancers of technology that works really well, so you could pull that cost off. There's a lot of different things, all these costs. You don't need Virtual Center. You don't need a hypervisor anymore. There's a massive cost savings. That's where these costs come way down. The maintenance goes way down. In containers, on the main servers providing the containers, you only manage one OS. All the things in the containers, if you're not doing this KVM thing, it's only one OS to patch, and you can run 1,000 containers on top of it. So very different, very cool, really where the world's going. And we'll talk to you later and see you on the edge.